Good morning, class. Welcome to the physics online classes for class 11th. In today's class, we are going to start the new chapter, that is the chapter 5 of your book, which is titled as Law Force and the Laws of Motion. Right? Because for the laws of motion it is related to the force, so we just have written at force and the laws of motion. But here you will be reading more about the laws of the motion. And you have, I think, this chapter you have read in the 9th class also. So just recall the topics and see what extra you are going to study in this class 11th. Okay. Now firstly, the first topic, that what the force is. Easily whenever someone asks us that what is force, we used to say that the push and the pull action is known as a force. But whether only this push and the pull action is known as force? No, because force can be of any type, and this acting force can be of any type and can change any kind of an object, right? Can have various types of effects on that object. So we can say not only the push and the pull action is a force, but something else is there. So to just explain how this force act or what is this force, we can say that force is an action word, right? Because something is acting on the object which is said to be the force, and this force is an external effect on that object. So this external effort which is kept on the object is said to be the force. It may be external effort or the external agency is asked to be said force. So we can say that force is an external effort which can move a body at rest, right? Because whenever the push or the pull action, now let us see some action words which tells us about the force, because we say that not only the push and the pull action is a force. Then what are the actions which we see every day that is a force? We know that whenever an object is used to be push or pull, then we used to exert some force on that object. Similarly, when we lift an object, then also we are exerting some force on that object. When we twist an object, then also we are applying force. When we used to press that object, then also we are applying force. So there are various actions in our daily lives that exert force on that object. So force can be of various efforts. So we can say that it is an external effect on the object, right? But what this force does, we know that whenever the force is applied on any object, there is some effects on that object. And what that does, like if you pull an object, then it just pull towards our side, that is towards the direction of pulling. And if the object is pushed from the side, then it just move away from us, that is, it is moving in the direction of the pushing direction. So we can say that we are just moving an object. So just moving the object is the work of a force? No, but due to force, some object used to move. And yes, some object size and shape also changes. Like if when we compress or we try to press some object, then some objects size used to change, or some size and the shape also changes, and sometimes the direction also changes. So there are various effects of this force, right? So we can say that force is an external effort which makes a body move, that is at the rest, and we can stop the moving body. And this moving body, what is does, so like if a moving body is there and if we want to make exert more force on that object, then that object will move now with more speed, right? So the moving object can make more speed by applying force on that object. So if you apply some force on any moving object, then the object can stop also, that we can bring that object into the rest position, as well as we can make the object to move with more velocity. So we can vary the velocity of an object, we can change the state of rest and change the state of motion, we can change the shape and the size of the body, we can change also the direction of the moving body by giving the force to that object. So this all are the force, that is the external efforts, and the action word which changes the different parameters of that objects. So what are the effects produced by the force? So the effects produced by the force are that the force can move a body at rest, it can stop a moving body, we can apply the force to make a moving body to stop, we can change the speed of a moving body, like when we pedal a cycle, we are just applying the force on the pedals of the cycle. If we want to increase the speed, then also we are applying the force, but now the force is trying to increase the speed, so we can increase or change the speed of a moving body. When we apply the force to make the direction change of the body, then we can just change the direction by applying the force on it. we can change the shape and the size of the body also. Like when we press or when we make the chapatis at home, we used to press the dough, when we used to apply the pressure on the dough, then it just changes its shape. And whenever it enlarges, we are just applying the force in the different directions. So we are changing the direction as well as we are changing the size and the shape. So these are the effects of the force through which we can just change the size, shape and the motion of the particles. So firstly, this force was given by the Aristotle. So Aristotle's fallacy was that he was a Greek philosopher. He stated that the motion of an object is done only when the force is applied. So he said that force is a necessary effort that keeps a body moving with the uniform velocity. So if we want to make a body move with a uniform velocity, so some force should be applied. But after that, the other scientist named as Galileo, he also entered in 1510. This is about the 1500s theories which Galileo gave it, and Aristotle was it's more ancient, that it was given in the maybe in the century of 300 to 400, in between the era of 300 to 400 BC. And after that, in the 1560 and about the 1600, and that era, Galileo had explained and proved that the Aristotle's views were wrong. He observed that just to make an object move, the external force were necessary. But this external object, to move it, not only the force is responsible, but this force is making to oppose the other force acting on that object. Then only we are able to move, right? If we are having the play in the tug of war, like both of them are just trying to pull each other, so some force is applied by each other, right? So if one force is acting on that object, can we say that the force is applied and can the body move? No, because we have to apply both the forces on both the ends of that rope, right? So here we are just applying the force against the opposing force, right? Opposing force is maybe gravity, it may be friction, and many other forces are acting in our region. But we can say, to maintain the state of uniform motion of a body, no external force is applied. But if there is no friction, then the external force is also not working. So we just have to get against the friction to make the body move, right? Because friction just allows to stop us, because it works only on the rough surfaces, right? So force is always acting against the friction. So external force should always oppose a frictional force to make the body move. So here he proved wrong the Aristotle, because Aristotle said that force is only the necessary things to keep a body move with a uniform velocity. But Aristotle said not only the force, but the friction is also there which is opposing this force. So we have to apply the force against the friction, then only the body can be moved with a uniform velocity. So the force have various concepts. In the previous classes of class 8, in the middle classes, you may have learned that the forces are of two types, that is contact force and the non-contact. What the contact was, that contact force which when we apply the force, we have to be in the touch of that object, that is the object should be in the contact of that force. Like when we have to push an object, we should touch that object and have to pull it or push it. So pushing and the pulling action, then we have to be the contact with that object. So we can say that the muscular forces are always in the contact forces. And similarly friction, now only we say that whenever the object comes in the contact with the other object, then only the friction can work. So we say that the friction works in the contact places. When the object comes in the contact, some force acts, and this force only acts in the rough surfaces. So we can say that is a frictional force, and these friction forces always acts opposite to the direction of the force. Okay, that is the frictional force. This both are the like an example for the contact forces. And similarly on the non-contact forces, we used to study about the electrostatic forces, like the charges producing. You will be studying this in the class 12th also, that is electrostatic force, magnetic force. This all are the non-contact forces, that one charge apply the force on the other charge, that is the stationary or the moving objects. And similarly a moving object tells that magnetic field is also produced around it. So we can say these are the non-contact forces. Like when we bring the iron nail towards the magnet, so this is not necessary that when it touches the magnet then only it can attract. To some distance also it attracts. So we can say that is a non-contact force. So we have to study more about this. So today we will be seeing that some other forces are also there, which is the balanced and the unbalanced force. By the word itself you can understand what the balanced means, is that the forces are of the equal in the magnitude. So when we apply the equal magnitude on an object, then it is said to be the balanced. And if more to understand and to define, we can say that whenever the resultant forces are zero, that is the resultant force acting on the object is zero, then the forces are said to be the balanced force. How this is said, if you see the example over here, an example including our daily life, like if you are pulling an object towards you with some force of 5 Newton. Let us consider that you are pulling an object towards you with a force of 5 Newton, and someone of your friend is also pulling that object towards him with a force of 5 Newton. So both of you are trying to pulling that object towards yourself with the force of 5 Newton. So both of you are just pulling that object with the equal force. So the both of the forces are balanced, right? Balanced forces are acting on the object. So the object will not move. Now the object will not move. So the balanced force does not enable the body to move. So it does not change the state of the rest or the state of the motion. We can say that the balanced force just makes the body to be stationary, because if we try to move or the push or the pull the object with some force, then we can say that force will never allow the body to move, because you are also pulling that object towards you with some force and the other one is also pulling the object with some force. So both are trying to pull that object with the same forces. If someone's force increases, then the object can move towards him, but now both the forces are same. So the object will remain constant and both the forces will be of equal magnitudes, that is of 5 newtons. So the balanced forces should be of equal magnitudes, but both are pulling the object towards their direction and both the directions are in the opposite way. So we can say that the equal and the opposite forces acting on that body. So we can say that one, if the opposite direction is of B body and you are the body A, then the body B will be considered as minus 5 Newton, because it is the opposite direction for the body respected towards the body A. And if it is body B, then according to the respect to the A, we can take the body B as minus 5 Newton. So any of the object will be of the minus 5 because it is in the opposite direction. So when these two forces acting towards each other in the opposite direction of equal magnitude, so what will the resultant force? We know that the resultant force will be the sum of both the forces. But one force is 5 Newton, the other one is 5, but both are in the opposite direction. So one is 5 and other one is minus 5. On adding this 5 and minus 5 together, we can say that it is 0. So the resultant force should be 0 for the balanced force. Similarly, for the unbalanced force, the force should be increased, that is one should be more than the other force or the other one should be less than the other force. So there should not be the equal force. So we can say that maybe in the equal direction or in the opposite direction, but the magnitude should not be same, or the values may differ each other, like one is greater than the other or the other one is lesser than the first one. So we can say that here the unbalanced force should be of not of equal magnitude, and as well as the resultant force should not be equals to 0. Like now if we are pushing an object, the other one is pulling the object. Now if you are pushing, the direction will change, right? The pushing and the pulling will be in the same direction. Now pulling the object towards you with the 5 Newton, the other one is pushing that object with 5 Newton. So now you are trying to moving that object in the same direction itself. So what is the resultant force will be? Sum of both the forces. So one force is 5 Newton, the other force is also the 5 Newton. So 5 plus 5, there will be the 10 Newton of the force applied on that object, and these object will move to one side itself where you are pulling and the other one is pushing. So both will act in the same direction. So here the force will be 10 Newton. So the resultant is not 0. So this force is said to be the unbalanced force. So balanced force and the unbalanced, some other calculation also you can say that balanced force does not allow the body to move. It just makes the body at a stationary position, because you are applying the balanced equal and the balanced forces, the body will not move. And for the unbalanced force, if you try to move that object, then the body will move to one side. Where the force is greater, the body will move towards that force. So we can say that whenever the body moves to one side, so the force can make the body to move or make the body to come to rest. So we just changes the state of rest for the motion. Okay, so the balanced and the unbalanced force. Now we will say what is the force of friction. Now only I say that the force of friction acts whenever the two bodies are in the contact. Not the two bodies, we can say that the surface of the ground. This ground also used to show the force of friction. So it can be defined at it is the force which is acts always to the opposite to the direction of the motion of the object. So it is opposes the motion of the object. This is the force which opposes the motion of the object. So it always acts in the contact between the surface and the body, and these friction only acts in the rough surfaces, not in the slippery surfaces or in the soft surfaces. So friction increases with the increase in the roughness of the surface. The forces always increase with the roughness of the surface, and as the surface is maybe said as smoothened, so with the smoothening of the surface the friction also decreases, right? So friction always acts opposite to the direction of the motion of the object. So like the ball is rolling on the ground, and now after rolling it never rolls with the same velocity always. It comes to the deceleration also you can say, and the velocity also decreases, and these decreases is due to the friction. Now if you throw this ball in the rough surface, then it starts decreasing very fast, and if you throw this ball in the slippery surface or in the smoothened surface, it will take time to stop. So we can say that some force is acting on that object in the opposite direction, and this opposite direction force is the force of friction. So we can say that friction is the force which acts opposite to the direction of the motion of object. So object of the motion with the uniform motion will continue to move with the uniform motion if the force acting on it are balanced. So whenever the unbalanced force acts on the body, then the speed and the direction will change. We know that because it changes the speed of the direction on the motion of the body. So if the unbalanced force move, then they continue to move with the same speed. So we can say that the friction is kind of the force which allows the body to oppose the motion of the body. So here the second part of the first part we have learned what the force is. So the second part we are going to learn about the Newton's law. What this Newton's law is, we have already learned this in the chapter of class 9th also, that Isaac Newton, by seeing the motion of the object, he described that the motion of the object just allows or just applies some law, and they'll do this motion according to some laws. So these laws, he just observed the motion of the objects and told some laws, and these laws were said to be the Newton's law of motion. So he was a scientist, Isaac Newton, in 1600, because Galileo was also given in the 16th century, but he gave in between the era of the 15 to 16. So he gave in the era between the 16 to 17. He told that the body moving have three laws, and these three laws were said to be the Newton's laws of motion, three laws of motion, and these laws of motion still holds today. Okay, so every moving object still holds this motion's law. So this law of motions are given by the three laws. So the Newton's three law of motion were, in short, you just understand what these three laws are. Firstly, when object is at rest, then they stay at rest, and when the object is motion, then they will stay into the motion at a constant velocity until unless an external force is acted on it or an unbalanced force acted. So when it is acted upon by the unbalanced force, then it starts moving. So we can say that the object at rest and the motion will not change until and unless the external force is applied on it. Similarly, the second law, he said that force is equals to the product of the mass and the acceleration, and similarly it is directly proportional to the momentums of the object with respect to the time. And the third law, it is a reaction force, that is every action has an equal and the opposite reaction. So we'll see in detail what this force of law in motion tells us. In the first law of motion, we have read that whenever the object remains at rest, it tries to remain at rest, and whenever the body is in uniform motion, it just continues its motion until and unless it is acted upon by the external force or acted upon by the law of any of the forces, or any unbalanced forces acted upon it, then only it can move. So we can say that this is the first law of the motion, because we see around us that whenever the chair is lying over there, or we are sitting, or some ball is kept over here, or any object where you can see around you, that is pen, pencil, anything, books, or you know seeing the mobile, so anything around you is at the rest position maybe. So to keep it in the motion, we have to put some force. So like to see this mobile keeping down, so make your mobile down on the screen, keep it on the table. So when you are keeping this mobile on the table, you have to exert some force to keep it in the table. So some force is applied on that object to keep it in the motion, or to change the position or the direction of the object, we have to apply some force on the object. Similarly, when the moving object, some ball is rolling down, we have to stop it. So we have to apply some force and have to stop it. So this body remains as rest and remains at the motion only when acted upon by the external force. So when the external force is not applied on it, we cannot change the state of rest or the motion of the object. So this first law is also said as the law of inertia also. So here he told about the inertia. This is the tendency of an object. Inertia is the tendency of an object it is say that whenever the body is there, it is a tendency of every body that when it remains in the state of rest, then it try to remain at the rest, and when the object is at the motion, then it tries to remain at motion or continue its motion in the with a uniform velocity, right? So it just continues its motion. So we can say that the tendency of a body to remain at rest or to remain at motion is said to be the inertia. So for the first law, he told about the inertia itself, because he said that whenever the body is rest, it remains at rest, and whenever it is motion, then it continues motion until and unless external force is applied on it. Similarly, it is to the tendency of the object, that is inertia. So first law is also said as a law of inertia. An object at rest will stay at rest, and object in motion will stay in motion until and unless acted upon by balanced force. Unbalanced force is acted upon it. So this is the inertia. So inertia can also be said as the two types, that is law inertia of motion and the inertia of rest. What this inertia of rest tells us about, the tendency of a body to remain in rest is said to be the inertia of the rest. So whenever a body tries to be in the rest, then the body have to feel that it is in the rest. See an example, that whenever we travel in the bus or in the train, we know that a person standing in the bus, okay, or in the train. Now let us consider that he is standing and the bus is not started still yet. Now yet if when it starts, now the train is starting. We know that whenever the train starts, we just feel a jerk, right? And our body move backward direction. In the backward direction, we feel a jerk in the backward, and we move backward, right? Before starting, we used to fall. In the childhood time, we used to do that. Whenever the train moves, we used to fall back, right? And our parents used to hold us. So we can say that this backward force is what that force is, because our body is tendency to the rest, it is tending to the rest, because we know that the train is at rest, so we are also at the rest position. So the lower part of the body, that is the lower part, that the leg of our body is remaining at the rest with the train. But as soon as the body comes in the motion, the upper part of the body, that is loose, and it is tendency to move with the motion. So but our legs are at the rest, so they are not in the tendency to move, so they remain at the rest. So for seconds it remain at the rest, and after that we just able to hold ourselves in the motion. So we can say that whenever the tendency of a body to remain, and if you are standing in the bus or in the train, whenever the starts moving forward, then the body feels a falls backward, or it feels a force in the backward direction. So the lower part of the body begins to move along with the bus, but the upper part of the body remain at the rest due to the inertia. So that's why it falls backwards, right? Because the lower part in the motion, right? Because it is in the rest, so it is tendency in the rest. But now it is moving. So our body is also trying to move, but our upper part that is loose, it will move in the backward direction. Similarly, the second one is inertia of motion. The tendency of a body to remain in the state of uniform motion in the straight line or in the plane is said to be the inertia of motion. So inertia of motion, for example, a bus suddenly stops or the train suddenly stops. What we feel a force in the forward direction. Why this happens? Because the lower part is already comes to the rest along with the bus, but the upper part is loose, so it does not came into the rest position now. It is along with the motion itself. So our body remains at the motion. So the upper part of the body will move forward. As soon as the train stops, we used to move, get a jerk in the upper direction. So this is the inertia of motion. Okay, so after that we will see what the momentum of the body is, because by seeing this momentum we will be telling the second law of Newton. So what this momentum is, it is defined as the product of the mass and the velocity. So this is the linear momentum, because you are learning about the straight line. When you learn about the rotational motion, then you can understand what the angular momentum is. Now linear momentum, it is defined as the mass, the product of the mass and the velocity. It is denoted by the letter P, and P is equals to mass into velocity, that is m into v. And if the body is at rest, its velocity is 0. So there will be mass. The mass cannot be 0 at any time. So velocity can be 0. At that time the momentum can be 0. Okay. So if the body is at rest, then only the momentum is 0. But the moving body will have the momentum. So SI unit of momentum is mass into velocity. So it is kg meter per second. It is kg meter per second. So the body with a heavy mass can be said as having with the velocity or the momentum is high. But just understand it, whenever the mass of the body is less, then the speed of the body will increase, right? because if you throw a smallest body like the small ball, if you throw out, then it will move with a high velocity. And now just when you have a last metallic ball with a large mass and try to throw it, then you have to apply the more force also, but the velocity will be decreased because the velocity is less. So velocity is inversely proportional to mass, but momentum is directly proportional to mass. So with the increasing mass, the momentum will increase, but the velocity will decrease. So the moving body of the high mass will be less velocity, and the movement of the body with the small mass will move with a high velocity. So this is the momentum of the body. So from here, after telling the momentum, he told about the second law, that is the Newton's second law of the motion. Now what this Newton's second law of the motion tells us about? He told that the second law of motion, he defined what the force is, and he defined the formula for the force, right? So what this second law tells us about? So from here you will find this formula. So I just written it as F is equals to m into A. So what the second law of the force tells us about is the force is directly proportional to the rate of the change of the moment. First thing is that, and in some books or in somewhere also you will study that it is directly proportional to the product of the mass and the acceleration. So both are come from the one itself, and they both will be mean one only. So here you can study that the net force of an object is equal to the product of its mass and acceleration, that is F is equals to m into A. Now I say that there are the two definitions for the Newton's second law. One is force is equals to mass into acceleration. Now the second one, that is the Newton's second law of motion, it tells us that is the rate of the change of the momentum is directly proportional to the force, right? Now we have seen that force is directly proportional to the rate of the change of the momentum with respect to time. This is the relation for the second law. But to tell us, he had just described this derivation and told what is the formula for the F. Now we have seen that the rate of the change of the momentum. Now what we can say, if we say that the position of the change and the velocity of the body changes, so let the body with the final velocity be mv, because the product of the mass and the velocity is given by momentum. So p is equals to mv, so the final velocity is given by mv, and the change in the momentum will be given by mu, right? Because the initial momentum be mu and the final momentum be mv. So the rate of the change of the momentum with respect to time is given by the force. So if we take the m constant as a common, then v minus u upon t. And what this v minus u upon t shows us, that is the acceleration, rate of change of velocity with respect to time is given as acceleration. So force is equals to mass into acceleration. From here he told the formula for the force, that is force is equals to m, which is there, and this v minus u will be changing into a, that is force is equals to mass into acceleration. Here acceleration is a vector quantity and force is a vector quantity. So this is the formula from where he derived the force, that is mass into acceleration. And what is the unit for the force? It is Newton, which is given by the letter capital N. It is Newton in SI unit, that is Newton in SI unit, and force in the CGS unit is given by dyne, not dyne, it is dyne, okay, it is 9. So this were the two laws of the Newton's second and the first law, and here we are going to see the third law, that is for every action there is an equal and the opposite reaction. You may know this better because whenever we throw a ball to the surface, like whenever you bounce a ball in the wall, then we used to get the ball in the same force, rather than come with the same velocity. So whenever you apply the force on any object, then that object will apply the force on us in the same equal magnitude but with a different direction. So the equal and the opposite forces are act on the object in the opposite direction. So this is the third law, that every action has an equal and the opposite reaction. And if you want to see this in your real life, give a slap to a person, you will get the next slap in some seconds itself, that is the action will have the reaction also, right? So we will see some numericals related to this, that is here from book. You can see the refreshers, so just use the refreshers, like okay, there are the two refreshers, that is the SL Arora and the Pradeep. So both of it you can use, but SL Arora is good for the concept and Pradeep is good for the numericals, because number of the numericals in the Pradeep is more and the number of the concepts in the SL Arora is good. So you can use both of it because both of it is same, because it depends on your potential how you are reading, it is not on the book. Okay, so see the first question. If you are able to see if the car of mass 1000 kg given the mass, so write it as m, that is given as 1000 kg. You just think this is the concept for your numericals, that whatever the given part is there, just write it first, then you will get what you have to calculate. Second thing, it is moving with the velocity 10 meter per second. Here it is written that it is acted upon by the force of 1000 newtons. So 1000 newton force is acted on it, but in the forward direction. So let the force acted on it, that is the first force, that is the forward force acted on it, be 1000 newton. Now it is retarded force. The other force, retarded means it act in the opposite direction. Both the F1 and F2 will be acting on the opposite direction. So the second force F2 is given that the retarded force acts in the other direction will be 500 newton. So what it can be given as that the change in the force will be given as the resultant force or the net force, right? Net force is given as the change in the forward force and the resultant force. So F1 minus F2 will be given as 1000 minus 500, so it will be 500 newton itself. So force is also given here, that is F is equals to 500 newton. So we got it, F is equals to 500 newton. So to find out what we have to find out, that is the what is the velocity after 10 seconds. Now we have to find out the velocity after 10 seconds. So we have to find out the velocity, but we know that the equations of motions are there for us to find out the velocity, acceleration and time, but there is no need for the mass and the force. So we have to find the acceleration first with the use of this force and mass, so that we can use the equation of motion. Like for force is equals to mass into acceleration, we have force as 500 newton, that is the net force acting on the body, and mass was given as 1000 kg, and acceleration be a, where the a will be 500 upon 1000, which is 1 by 2 or 0.5. Now you got the acceleration. We have to find the velocity after 10 seconds. Now the time is given, right? Time is given as 10 seconds, t is given as 10 seconds, and mass is given from where we have find out the force, and we have the velocity also, that is we have to find out after the time. So we have to find, so calculate, write it as v, and we are having the acceleration which was 0.5 or 1 by 2 meter per second square. Similarly we are having the time v, u and at. Now we know that when the body started up, it started with the velocity 10 meter per second, so it will be the value for u. So u is given, we have to find, and t is given as 10 seconds, and we have to find the acceleration also we are having, that is 1 by 2. So using this 4 words, we know that the first equation of motion will be used, that is v is equals to u plus at. So using that equation we can find out the value of the velocity after the 10 seconds of that body. So v is equals to u plus at. Value of u is given as 10, value of acceleration is 1 by 2 or 0.5 and 10. So it is 2 5s, and 10 plus 5 will be 15 meter per second. Got it? So to find out the velocity, we have the equation of motion, but the force and mass is not used in the equation. So we can use the other one, that is force upon mass is given as the acceleration. Similarly, see the next question, that the bullet of mass 0.04 kg moving with the speed of 90 meter per second. Here the mass is given as 0.04 kg, and it is moving with the velocity 90 meter per second. So he covered a distance of 60 centimeter. Now distance is given by s, okay, because we will be using equation of motion. So s is given as 0.60 centimeter. If we convert it into meter, then it is 0.60 meter, because it was 60 centimeter. On dividing it by 100, we will get 0.60 meter. Similarly, what is the question, that what is the average resistive force? We have to find it here, force. And force, for force, what is the formula? Mass into acceleration. But we are having a force as mass is also given, but velocity is given, not acceleration is given, but we are having s with us, so we can find the acceleration with the help of the equation of motion. So we are having v, and since the body is started from the rest, right, bullet of the mass moving with the speed, so it enters into the wooden block, so it will stop. So v's value will be 0, that is final velocity will become 0, and u is given as 10 meter per second, so this is u, and 2as, we have to find the a, so a will be used in this equation, that is the third equation will be used, because in second and first time is used, but here time is not given. And for displacement it is 0.60 meter. So v is 0 and u is 90 square, that is 90 meter per second square. And secondly 2as, that is 2 into a into s. So 2 into a into for s it is 0.60 meter. So 90 square will be 8100, right, which will be equal to 60 into 2, that is 60 upon 100 into 2. 0 0 cancel, 2 5s. Now 5 will be multiplied. 8100 into 5 upon 6 equals to acceleration. So 6 and cancel it with 3. 32700, 3900. So it will be cancelled and give that it is 2a, that is 6750. It will be 6750. So it is 6750 meter per second square, because it is acceleration, and this is the retarding because it is stopping, so it will be taken as negative. So we have to find out the retarding force, that is mass into acceleration. Force is equals to m into a. Mass is given as 0.04 kg and acceleration we find it now only, that is 6750 meter per second. So we just have to multiply both the values, so we get the force in the unit of Newton. The third question, the force of 72 dyne. Now this dyne is given as force in the CGS unit, right? So that this dyne is inclined to the horizontal of an angle 60 degree. Here angle 60 degree is given, it is inclined to the horizontal. Remember it, whenever we taken as the horizontal, then it is cos theta is used, you know the resolution of the vectors, and when it is vertical, then it is taken as sin theta. So here it is making an angle theta equals to 60 degree and it is inclined at horizontal, so it will be cos 60 degree will be used. But we know that f is given as f cos theta, because it is horizontal force is used, so f will be resolved as f cos theta. So f cos theta, here the value of the f is 72 dyne and cos theta is cos 60 degree. So cos 60 degree is 1 by 2 into 72, that is 36 dyne is given. And other thing what it has asked in the question, that find the acceleration in a mass of 9 grams. So the mass is given as 9 grams, m is equals to 9. We have to find a, right? We know that force is equals to mass into acceleration. So mass was 9 grams and acceleration is given as not given, so we have to find out acceleration. What the force was, 36. So 36 upon 9 we will get the acceleration. It will be 4 meter per second square. This is the value for the acceleration. Okay, so we have got the numericals, that how we have to solve last numerical, that is a scooter is moving with a speed of 36 km per hour. So it is moving, so it is a value of u, and he say that it will be standing in the middle of the road. He applies the brakes, so on applying the v will be 0 and u is given as 36 km per hour. And it is given that if after 5 seconds, just in the time to save the child, he just he applied the brakes in the 5 seconds, so time is 5 seconds. And what else it is given, that calculate the average retarding force. We have to find the force, and the only formula is mass into acceleration. Here the mass is given that it is 300 kg, so mass is given as 300 kg, but acceleration value we have to find. So using this we can find out the value, that is VUT is given and we have to find AT. So this is the formula for the first equation of motion. V will be given as 0, U is given as 36 and A into 5. So it is 36 upon, it is not 36, okay, we have to change it as meter per second. Sorry, it is given as 36 km per hour, so 36 into 1000, and down you have to write as hours. So 1 hour has 60 minutes and 60 seconds, so 0 0 cancel, and 6 6 and 6 will also cancel, so only 10 meter per second is left. Okay, so we will be using 10 meter per second instead of u, plus a into t, that is 5 into a. So it will be minus 2 meter per second square. Acceleration is minus 2 meter per second square. So on putting this value in the force is equals to mass into acceleration, we can get the value of force. So force is equals to 300 into a, that is 2. So it is 600 Newton. That is the value of force is 600 newtons. So have you got this numericals at how you will be solving the numericals regarding the second law of motion or the first law of the motions, right? You can see more examples are here, but we'll be talking about this in the next class also. And if you want to see here, you can understand, you can solve it your by own. That burst starts from the rest accelerating uniform velocity with 4 meter per second square. So u is given as 4, but at t it started from rest, so v will be there, but u will be 0. So horizontal velocity, so it will be vx, and now we know that u is equals to 0, and a into t, acceleration is given as 4 and t is given as 10. So multiplying on this, we can get the horizontal velocity vx is equals to 40 meter per second. And what else is written here? A stone is dropped out of a window of the bus 2 meter per high. See here, you are just throwing a object in the downward direction from a height, so it is moving in the vertical direction, so it will be affected by g. But in the upward direction, that is moving horizontal, the g is not working, or it is not acted upon by the gravity, acceleration due to gravity. So g will be taken as 10. And here what the time taken by the body, the acceleration of the stone at 10.2 seconds it was given. So time is taken as 10.2 seconds and g is taken as 10. So v is equals to u plus at we can use here, but instead of a it will be g. So initial velocity will be 0 because it is thrown from the rest. So it is 0 plus 10 into 0.2, that is 2 meter per second. So magnitude of the resultant velocity of the stone is, we know that vertical component can be given as the under root horizontal component plus vertical component plus square. So this is the resolution for the velocity. So under root 40 square plus 2 square, it will be 1604, that is 40.4. Now whenever the acceleration is dropped, its acceleration along the horizontal is 0, it has only the vertical acceleration. Okay, it will have only the vertical acceleration, because the question was that that acceleration, find out the acceleration at 10.2 seconds. Then the acceleration is 10, but it is only in the vertical direction, not in the horizontal direction. Similarly, see here, the two forces are acting. We know that the forces are the vector quantities, so it will be adding and the summing up according to the vector law of addition. So we know that whenever the two vectors are added, then it is a square plus b square plus 2ab cos theta. You have remembered this, that the resolution of the vectors in the parallelogram law of vector and the triangle law of vector additions. So it was f1 square plus f2 square plus 2f1 f2 cos theta. You were using this because theta was given there. So angle is 60 degrees, so use cos 60, and cos 60 is 1 by 2, and the values of root 2 into root 2 will be 2 into 2 4, and it will be cancelled out by the 2. So the value is given as under root 182, and if we have to find out the root, then it is 13.49 Newton. So to find out the acceleration, that is the ratio of the force and the mass, or the force is equals to mass into acceleration. So from here we have found out the value of acceleration. Now what is the question? Find acceleration. We have already found out the acceleration. Now we have to find out the distance. So for distance we are having only formula of the second equation, and the third is also there, but we can find by the second equation, that is s is equals to ut plus half a t square, because the t is given, that is after 10 seconds. So we will be using the second equation of motion. So u is 0 because it started from the rest, and the other thing that is half a t square. So a we have already found in the first, that is a is equals to 0.01349 meter per second square, and a is given as 0.0139, and time is given as 10. So on multiplying both of this, we will be getting 0.6745, which is the displacement of the body, or the distance covered by the body. And velocity, for velocity we will in the first equation, v is equals to u plus at, u is 0 and a is 0.01349 meter per second square into 10. So it will be 0.1349 meter per second. So this was the velocity, acceleration, and the distance covered by the body. Now the last, that the block of the metal weighing 2 kg is resting on the frictionless plane. So now it is resting. It is struck by a jet releasing water at the rate of 1 kg per second. Now what is here? 1 kg per second. Okay, so kg per second is the unit of mass per unit time, right? Mass per unit time is given, and at a speed of 5 meter per second. So velocity is also given. So we know that force is directly proportional to the momentum, and momentum is given by mv. So m is constant. By keeping the value of m outside, we can write it as dv by dt. Sorry, dm by dt, if v is kept out. So dm by dt. Why we are taking it as dm by dt? Because kg per second is given. So dm by dt is given by 1 kg per second, and the velocity is given by 5 meter per second. So on multiplying, we got the force is as 5 Newton. So to find out the acceleration, force is equals to mass into acceleration, and the mass is given as the 2 kg So block of the metal is of 2 kg. So on dividing the force and the mass, we will get the acceleration, that is 5 upon 2, 2.5 meter per second square. And the last question, that the body of mass m is moving along the x-axis such that its position coordinate at any instant is t. Okay, at any instant it's t. So we can say that a, b, c are the constants here, right? And it is moving at an instant t. So what is the force acting on it? A change in the displacement, that is the position change, is given by the velocity. So if we differentiate once, that is dx by dt is given as a velocity. We know that for the differentiation, the power comes at the coefficient form and the one power will get decreased, that is 4 will come in the coefficient, that is 480, and to the power 4 will decrease by 1, that is 480 cube. Similarly 3 will come front and the 3 will be reduced to 2, so it will be 3bt square, and for t it is the differentiation of the t, dt by dt will be 1. So C, again we will differentiate because this is the velocity, and the velocity, rate of change of velocity with per unit time is given as acceleration. So again on differentiating it, it is 1280 square minus 6bt. So this is the mass and the acceleration which is given by the force. So mass is not given here, so just there will be a relation that m into 1280 square minus 6bt. So this is the relation for the mass into acceleration and the force on the body. So this were the numericals, force, and then 3 laws of the Newton's. So if you have any query regarding this topic, and if I am going very much doing hurry up or doing very fast, then you can just tell me that, because you are not having much time, and I too got the 15 days itself to complete this, and before 27 we have to do the practicals and have to do the theory classes also. So it will take fast only, and in some sessions after completing the chapters, I will be starting telling you the MCQs. We will be taking the sessions after this lessons of MCQ itself. So here you just understand what the concepts are. After that we will be solving the MCQs so that you can get ready for the term. Thank you.